Now let's define the slab section. For this project, we are using a concrete slab. First, we need to determine the slab thickness according to the code. According to ACI section 8-3, slab thickness is calculated as ln divided by 33, where ln is the longest span. For our project, the longest span is 5 meters or 500 centimeters, so the slab thickness will be 500 divided by 33 equals about 15 centimeters. However, since the architectural plan shows cantilevered areas, we also need to calculate the thickness for those slabs. According to ACI section 7-3, the thickness for cantilever slab should be L divided by 10, where L is the cantilever length. In our project, the largest cantilever is 1.7 meters or 170 centimeters, so the thickness for these slabs should be 170 divided by 10 equals 17 centimeters. To be conservative, we'll go with the final slab thickness of 20 centimeters. To define the concrete slab in ETABS, go to Define, Section Properties, Slab Sections. You'll see a default slab section named Slab 1. We'll modify this one. Name the section S20. When modeling concrete slabs, you can use either shell-thin or membrane elements. Shell-thin is more accurate theoretically, especially for cantilevered slabs where no beams are modeled at the free edges. However, for other slab areas, if we use shell-thin elements, the slab would participate in lateral load resistance. Since design codes don't really go into detail about how lateral force affects slabs, it looks like the general preference is for slabs not to be involved in lateral load bearing, so we are going with membrane elements. So for this project, we'll use membrane elements for most of the slab and shell-thin elements only for the cantilevered parts. First, for the membrane slab, name it S20 mem, set the material to concrete, and select membrane as a type. Everything else can stay as is, so click OK. Next, to define the shell-thin slab, click Add Copy of Property, name it S20 Shell, and just change the type to shell-thin. Click OK to save.